Good day. I want to talk about gravitational potential energy and where it came from. Okay. So I want to start with an example. Consider a physics book, right? So this is a book, right? And this is the Earth. So I'm actually drawing a system schema. So what is the interaction between the book and the Earth? You say, of course, that is the gravitational force, right? Now, what if we define this thing, the system, to be both the book and the earth? That means, what is our internal force? Our internal force is gravitational force. According to our lesson, if we have a system of two objects where one of the object is the earth and the other is an object much smaller than the earth and near the earth's surface, and that the only internal force between them is a gravitational force, we can define energy for that system known as the gravitational potential energy. So how do we do that? Now, let's say, for example, we there is another player involved, maybe a person, and the person is applying a force, external force in this case, right? External because the person is not part of the system. And what if by applying this external force, applied force, the height of the book increased? So let's create an y-axis. And let's say this is the floor. And let's say that the initial position of the book is y initial. And then after applying a force, applied force, this external force, let's call this the applied force. The book now has a final position of yf. So what changed, right? Something must have changed. Well, what changed is that the height, the book is now at a higher place. And according to our lesson, there is a change in configuration. So, external force applied to the system, the book Earth system, causes a change in configuration of the system. Right. Configuration, which means that the earlier configuration, the first configuration is that the book is closer to the floor at y initial. And the later configuration, the change in configuration caused by the external force is such that the book is now at a different position y final. Okay. So the point is, this change in configuration causes a change in the energy of the system. So what kind of energy is changed in the system? Did the kinetic energy of the system change? Like, did the Earth move? Well, we can approximate the Earth to be stationary because it is so big compared to the book. But did the book make any motion? Yes. From yi to yf, the book moved and there was kinetic energy during that process. But when we consider the time when the book was already at y final, it has no kinetic energy anymore because it is already stationary in y final. So the first configuration where the book is at y initial, the kinetic energy of the system is 0. Now, the second configuration where the book is now at Y final, stationary, the kinetic energy of the system is still zero. But there's got to be a change. How do we know that there's a change in the energy? Well, because when we release the book at Y final, the book dropped at much greater kinetic energy. It speeds up to higher, greater speeds before it hits the floor. So some energy must be stored somewhere, right? And this energy storage gave this system more potential to do more work because it dropped at a much faster speed. So that's where the word potential energy comes from. So the change in orientation, let me write that down. Change in orientation of the book Earth system cause results in a change in gravitational potential energy of the system. Namely, the system now has more potential energy when the book is at Y final than when the book is at Y initial. Now, we have to quantify. How do we quantify that? How much energy is stored or how much is this change in potential energy? What we can do is clearly, since this change in potential energy has something to do with the external force that is applied by the person, let's use that, no? Let's use the idea of a work, the work done by the applied force, right? The external force. The applied force is we dot product it with the displacement, where the displacement delta R is Y final minus Y initial. And consider that the force that we apply is equal to the weight of the book, mg. We want to do that so that we can get the book going from Y initial to Y final at constant velocity with no acceleration. Therefore, we can substitute force external as mg and delta R is Y final minus Y initial. mgy final minus mgy initial. So the work done is the external work done is equal to mgy final minus mgy initial. So there's something special about this expression, mgy final minus mgy initial. So it's like initially this is the expression, but because of the work, this is the new expression. So this expression is what physicists decided to label as the UG, or the gravitational potential energy. UG is mgy. This expression, or you're probably more familiar with mgh, is the formula for potential energy. Only when the system is composed of objects near the Earth's surface, and because in that case, G, small letter G is constant, 9.8 meters per second squared. So that's it. This is the formula for gravitational potential energy. And you can say then that the external work, in this case, causes a change in gravitational potential energy. So I hope I explained to you a little bit what the gravitational potential energy is. And next meeting, we will just solve more problems. Thank you.